In this video, we're going to do a few more examples of empirical formulas, and then we're going to jump into some molecular formula. So this example is very similar to the previous example we did for empirical formulas, except you'll notice that there's an extra element. I'm going to go through this one a little bit faster since we're used to the steps at this point. So again, our first step is to go from percent to mass, and to do that, we assume 100 grams. And so we get our percentages directly converted into grams. So 57.14 grams, 6.16 grams, 9.52 grams, and then 27.18 grams. Now we have to do our mass to moles. So remember, that's simply the moles is equal to mass over molar mass. And so I'm going to do that pretty quickly here. I'm going to divide this by the molar mass of carbon, which is 12.01 grams per mole. Cross out grams, and you're left with moles. I'm going to divide this by the molar mass of hydrogen, which is 1.01 grams per mole. Cross that out and you get mole. I'll divide this by the molar mass of nitrogen, which is 14.01 grams per mole. Cross out grams, and you're left with mole. And divide this by the molar mass of oxygen, which is 16.00 grams per mole. Cross this out, and you get moles. So let's go ahead and figure out what those are in our calculators. 57.14 divided by 12.01 gives us 4.577 01915 moles. The 6.16 divided by 1.01 gives us 6.099009901 moles. And then 9.52 divided by 14.01, we get 0.679514632 moles. And then over here we get 27.18 divided by 16, 1.69875 moles. Now we divide by small, so the smallest value seems to be the value for N. So divide by 0.679514632 moles. And that's divided by itself, so it's 1. I'm not going to rewrite this every single time here. I'm just going to write divide by moles of N, divide by moles of N, and divide by moles of N. But you know that we're dividing by the smallest value, which is this. I'm just rewriting it as that there to illustrate that. And we get the following numbers. So divided by 0.679514632, 2.499946, 46167. That we know we can't round. 6.0999901 divided by 0.679514632, and we get 8.975669872. And this one we can round because it's in our little rounding region there, so we get round up to 9. And lastly, 4.577 divided by 0.679514632. And we get, I think that one's off. Let's try that again. 4.577 01915 divided by 0.679514632. And I get 6.73. It seems a little off for me. Let me go back and retry that. So we had 57.14 divided by 12.01. That's why. I forgot a 7 over here. So my answer seemed a little bit off. 4.75771915. So now let's retry that. Divided by 0.679514,632. And I get 7.001618, etc., etc. And this one I can round to 7 because it's within our little rounding region. So the other one I can't really round is this one over here. This is our problem. So we need to multiply till whole, and this is about 2.5. So I think if I multiply by 2, it'll solve my problem for me. Everything has to be multiplied by 2, so this will become 14. This becomes 18. This becomes 2. This becomes, so if you do 2.499946167 times 2, you get 4.99998, so on and so forth. And this can now be rounded because it's within that rounding region to 5. And so now we found our final or our empirical formula. So therefore, the empirical formula is C14H18N2O5. That's our empirical formula for aspartame. We'll finish off with the example in this table over here. And it's essentially the same process, just this time it's a little bit easier because we only have 2 elements. So we have our percent composition given to us. Our first step is percent to mass. We'll assume 100 grams. Make sure we write that out. And so for sulfur, we have 50.05 grams. For oxygen, we have 49.95 grams. Mass to moles, remember, moles is the mass divided by the molar mass. So we'll do divided by 32.07 grams per mole over here. And over here, we have divided by 16.00 grams per mole. Cancel out grams. And we get 49.95 divided by 16. Here we get 3.121875 moles. And here we get 50.05 divided by 32.07. 1.5606485881. We need to divide by small. So let's divide by the smallest mole value, which happens to be this 1.5606485881 mole. So this is mole and mole. Mole cancels out, and this is equal to 1 since it's divided by itself. Here we have divided by 1.5606485881 mole. And so we get 3.121875 divided by that answer, 2.000370255, which we can round. That's great. We can round this time to 2. So there's no need to multiply till whole because everything's already whole, 1 and 2. And so therefore, the empirical formula is S1O2 or simply SO2. You don't have to put S1 because the 1 is implied, so you can simply write it as SO2. There's another practice problem over here, example number 4 for empirical formulas. We can try it out. I recommend you pause the video and try it yourself. Notice there's no table provided to you this time, so you need to make sure you follow the steps properly. So we're going to first do the percent to mass. And to do that, we're going to assume 100 grams. And I'm going to carry the steps out a little bit differently this time. I'm going to just put my my element symbols side by side and put the numbers right next to them so I can do it in one neat, streamlined process. So I have magnesium, and it's going to be 72.2 grams because of the assuming 100 grams there. and nitrogen, 27.8 grams because of the assuming 100 grams. Next, I'm going to go and do mass to moles by doing the N is equal to M over molar mass. So I'm simply going to divide these by their molar masses, 14.01 grams per mole here, and then 24.31 grams per mole here from the periodic table. And we get, so 27.8 divided by 14.01, 1.984296931 moles. And for the magnesium, 72.2 divided by 24.31, 2.969971, 205 moles. Divide by small. So divide by so step 3, divide by small. So we'll divide by the nitrogen. So divide by 1.984296931 moles. Mole cancels out. Divided by itself here, 1.984296931 moles. Moles cancels out. This simply gives you 1. And then the 2.96 divided by 1.984296931 is about 1.496737,287. I cannot round the 1.49 right now, so I need to multiply until whole. And it looks like about 1.5, so I think I can do times 2. So if I do times 2, this becomes about 2.99, and there's more there, but we can round that to 3 now. And this becomes 2. Don't forget, everything gets multiplied by 2. And so therefore, the empirical formula is Mg3N2. And that's our empirical formula. So in this lesson, we simply finished some examples for empirical formulas. In the next video, we're going to take a look at molecular formulas and do a few examples with those.